Hello friends, welcome to my channel. Let's have a look at problem 2386, find the key sum of an array. So in this video, we're going to describe a strategy to generate all the possible subsequence sums from the largest possible to gradually smaller ones based on tree and heap. So first, I'll read through the statement to digest the requirement of the problem. And then we do some analysis, and finally we look at the code. First, let's look at the statement. So we are given an integer array called nums and a positive integer key. So we can choose any subsequence of the array and sum all of its elements together. So we define the key sum of the array as the key's largest subsequence sum that can be obtained. So these sums are not necessarily distinct. So we are required to return the key sum of the array. So a subsequence is an array that can be derived from another array by deleting some or no elements without changing the order of the remaining elements. So this paragraph actually emphasizes that we are considering subsequence, not subarray. So here is a note. So note that the empty subsequence is considered to have a sum 0. So here are two examples. So example 2 actually returns 10. In other words, 10 is the 16th largest possible subsequence sum. So after our analysis, so this output should be easier to digest. So for now, let's look at example 1, because the length of the nums array is short, is 3. So we can actually list all the possible subsequent sums and then pick the 5th largest one, that is 2. So this is for example 1, very easy to digest. So but the length of the array can be as long as 10 to the power 5. So we need to come up with generic method to get the output. So another thing is that the elements in the nums array is bounded in absolute value by 10 to the power 9. So we need to find a sort of effective method to do the job. So finally, k is larger than or equal to 1. So and less than or equal to the minimum of 2000 and 2 to the power n. 2 to the power n actually comes from the length, right? So for each of the elements, so we can choose to include in the subsequence or not. So there are 2 to the power n possible subsequences and non-empty ones, right, for this problem. So with that said, so let's look at the method here. So the method is based on heap and tree. So here the heap and tree plays the role of hyper or container. So essentially, we are going to generate the possible numbers from largest to smaller ones with early stopping triggered by key in this problem. So here is a comment before we look at the idea and walk through a procedure. So this problem provides a use case for a general strategy, and it's good to understand the final details below. So the idea is the following. So we are going to find the largest possible sum and starting from there, and then using backtracking like procedure to generate the gradually smaller numbers. So we start from the largest possible subarray sum m, which corresponds to the sum of non-negative elements in the original nums array. And then we actually consider the absolute value sequence of the original nums array. So we subtract this absolute value from small to large from m. So if the absolute value or the original elements in the nums is negative, corresponding to an absolute value, then so if we subtract the absolute value, it's corresponding to adding the negative number to the subsequent sum. And if the original number is positive, corresponding to an absolute value, then if we subtract the absolute value, so this is equivalent to removing the positive number from the subsequent sum. So both way actually plays the role of decrements the number from the base. So to enumerate all possibilities, so we actually can generate a path to cover different combinations. So this can be done by repeatedly generating two branches at each point, with one always include a value at a given index, and the other always exclude the value at that index. So you're going to notice this in the code. So here is a walkthrough. So if k equals 1, so no matter what sequence array are given, so we must return the sum of all the positive numbers in the array, or 0, right? If there's no positive ones. So overall, we need to return the sum of all non-negative elements in the array. So this is for k equals 1. How to generate the smaller ones? So then actually we can use max heap to keep track of the largest subsequence sum so far. So to get the next smaller sum, so we know it can be three cases. So first is the same number, right? So if 0 is in the array, or we can remove a positive number, or we can add a negative number, right? So the next smallest one corresponding to, if we use the second and third operations, it corresponding to use the one with the minimal absolute value, right? So that's why we're going to consider the absolute value sequence corresponding to the original array. So actually we just comment on this paragraph, so we can actually consider sorting the absolute values of the original array. So this corresponding to each in each step we try to decrement the number as little as possible. So if we use max heap, so we can pop elements from the max key times. So actually here we can use this example to give you an idea. So here we add a -2 because we want to include negative numbers in the procedure. So the first largest subsequent sum is nothing but 8, corresponding to 3, 1, 4, right? So this is the corresponding largest one, the first. So then we want to get the next largest one. So if we look at this absolute 1, so 1 actually corresponds to positive 1 here. So we can subtract 1 from 8. So this corresponds to remove 1 from the previous subsequence. So we get 3, 4. So this has sum 7. So when we arrive at the next index, we're going to consider if we subtract 2 from the sum, right? So we can repeat what we did. So if we add -2, so because we minus 2 from 7, corresponding to add -2, right, to this. So we're going to have 3, -2, and 4. So we get 5. But also we need to consider at the last step, so we actually do not remove the 1, but we directly adding -2 from our subsequence 3, 1, 4. So that way we corresponding to 3, 1, -2, and 4. So this actually gives us 6. So in other words, so we have 8, we have 7, then we are going to have 6. So the third largest possible number, and then we have 5, right? So you can continue this procedure until we arrive at the end of the absolute value sequence. So this is actually the full detail. So for the state of the heap and the number, the largest number we get. So this is the largest number. So here we are using min heap in the Python implementation. So the return should be the negative of these numbers. So the largest one corresponds to the smallest, right? If we put a negative sign. So the largest sum is 8, and then we have 7, and we have 6, we have 5, and we have 5. So the fifth largest one will be 5. So with that said, so we are ready to look at the code. So it's good that after we explain the code, then you come back again to examine the procedure and the full details. So that way we will get a better understanding. So first, I'm going to find the capital M So which is so let me use m, little m, because this is a variable. So I'm going to sum all the things for x in nums if x is greater than 0. So strictly speaking, we should use x greater than or equal to 0. But let's use this one maybe. So this way, so we get the largest possible sum, and then we are going to use a heap. So priority, heap. So we are going to put the negative as the largest value. Then we put a 0 here, and then we also prepare the absolute values. So it's in sorted format for abx for x in nums. So this way, actually, we are making preparations to shrink the largest possible sum gradually. So so this is the purpose. And next, we're going to do pops. So for so actually, we can use a dummy variable for in range. So k. Then each time, so we're going to get a corresponding number, right? So it's a candidate and the corresponding index. So we're going to use heap pop. So we're going to pop from this heap, right? So then we are going to check if the I is less than the length of the corresponding values. So this actually is also the length of the original nums array. So then actually we're going to consider two branches. So one is we're going to push heap push. We push to this heap, and the values we're going to put is nothing but x plus values I, and then we move the index forward by 1. So here we using add. The reason is that so we are actually putting the negative sum into the heap. So here this x is candidate. That's right here. So this is the one possibility. And then actually we can also do a thing similar to backtracking. So if I is greater than 0. So in this case, so we're going to consider another branch, heap push. So we're going to push this one. So what we are going to do is actually, so our candidate, so minus the previous values at the previous index. We do not use that one, and then we consider this possibility, and then we move the index one step further. So this way, actually, the negative candidate is what we want to return. So this actually is a translation of the steps or procedures we demonstrated above. So let's first do a special case check. Yeah, it passes the first example. Now let's look at the second example. Yeah, it passes the second example. Now let's look at the generic case. Yeah, it passes all the generic cases. So I guess that's about it for this video. But let's emphasize one point. So it's actually good to understand the finer details and the general procedure for generating possible subsequence sums from large to small from this problem. I guess that's about it. Thank you.